So we get to see an application of matrix multiplication, why it is that you would like to do this idea of multiplying, turning, crashing things into each other. Okay? So matrices hold numbers. So here we got a company that supplies balls, bats, gloves to sporting goods stores. The following table indicates the number of items each store has ordered. So we could, if we wanted to, and we will, make this into a matrix. And the matrix will look very similar to what we had to begin with. And I guess I can write this here. This will be our matrix A. This is what was ordered. And sometimes what we'll do in our matrix as well is we will add on the outside some labels, PQRS, and oh my goodness. What should I do? Add an A for balls? And an A for bats? Oh no. I don't know. Yeah, they should have ordered other things rather than things that started with the same first two letters. I know. A good math teacher would have made a question where they bought something differently. But so we've got our total order, that's matrix A. Then cost per item as a column matrix B. So I'm going to go B equals, it's a cost, so this will be a dollar sign here. And we had balls were 8, bats 30, gloves 75. Ball, bat, glove. We could. There we go. It's like spelling sign without the E. Okay. It's so bad. Does he go? Kiss, kiss. Okay. Anyways. So we got balls, bats, gloves. Now, this is going to be key for the mathematics to work. Notice the order balls, bats, gloves matches up with the order balls, bats, gloves that we had previously. They will be in opposite dimensions, which will be important because question C says use matrix multiplication, create a matrix C depicting the total cost that each of the stores is going to pay. Now, C is going to either equal A times B or B times A. But the only way it makes sense, because this, if we put the dimensions, this has 3 rows, 1 column. Matrix A was a 3 by 3. So the only way I could multiply them together is if I went A, which is a 3 by 3, 4 by 3, thank you, 4 stores. A, which is a 4 by 3, and B, which is the 3 by 1. Now, in matrix multiplication, you know that these middle two numbers have to match, but in matrix multiplication in a word problem, not only do they have to match, but they have to match in what they stand for. Balls, butts, exactly the same as well. So the 3 by 3 has to match up, and the answer matrix that we're going to get, C, is going to equal a 4 by 1 matrix, 4 rows, 1 column. What did the 4 stand for? P, Q, R, S. Are you impressed that I remembered the order? And $sign for the 1. Now, the next thing I'm going to show you is that if you have a graphing calculator, we can do math on matrices on our graphing calculator. Because what would we have to do, right? We have A times B. I could put matrix B right here with the 8, the 30, and the 75. And does it make sense for store P? They had, if I take 70, 30, 20, that row, turn it sideways and crash it in. The 70 hits the 8, which balls cost $8 each. The 30, the bats would hit the 30. Bats are $30 each. And the 22 hits the 75, which is how much the gloves cost. How much is their total order? I would have to add those up. So now we're seeing how two matrices multiplied together has an actual purpose. It can figure out totals for us. And if you play around with the matrices, you can like, oh, this matches up, so that means I can multiply. Then I get new answers that have meaning quickly and easily. And especially if you have technology available. So on your calculator, okay, we're going to go to the matrix button, which is, couldn't read it on this one, right here. Yeah, it does, except you can't read it on the. So you go to matrix. We're going to edit one of these. We're going to edit matrix A. It was a 4 by 3. It automatically puts that in. I'm going to slide this over so I can see the numbers. And 70, enter. 30, enter. 22, enter. 60, enter. 20, enter. 19, enter. 70, enter. 15, enter. 24, enter. 50, 40, 12. So we've entered in our matrix A, and then I can go back to matrices, back to edit, and now matrix B. I can enter my 3 by 1, my 8, 30, 75. Excel could do very, very well, although I wondered, does Excel have matrix abilities, or do you have to set up each formula individually?
No, it has matrix.
Yeah?
Well, not necessarily, but you can do enough.
Well, yeah, and some of these have the same formulas happening, so you could copy your formulas down. But if we go into our regular calculations now, again, go to the matrix. If I type in matrix A, it comes up. Then I can hit the times button, and I can go back to matrix and then select matrix B, A times B, push enter, and I get 3110, 2505, 2810, 2500. 3110, oh my goodness, memory is not good. 2505, 2810, and 2500. Beautiful. And the other nice thing about your calculator is we just got this answer. We can now store it into our calculator as second matrix C. And now those numbers are stored in our calculator as matrix C in case we want to use that later. You, above the on button is the store button, and then you just select which matrix. You have to go back to matrix and select matrix C to store it in as matrix C. Okay? A 2% shipping charge. Does it make sense that matrix D would take matrix C, and to add 2%, you would have to multiply, oh, that's a big square bracket, times matrix C. So how could I do that quickly and easy on my calculator? I could go to my calculator, I could take that answer, I could just say I'm going to multiply that by 1.02, multiplying by a scalar. Now we have all of our taxes included. So I can store this one, in case I need it, as matrix D. That would be nice. I'm so old. I remember when they introduced GST and PST. Yeah. What? There's no sales tax. You buy something, it was $1.25, and you paid $1.25. I don't know. I have to. Yeah, that would be something to Google. I would say it was when I was in high school, maybe junior high, 1940s. Thanks a lot. Anybody figure it out? When was GST added? 1989. Oh, junior high. I was an aspiring 12-year-old. Oh.
GST was added in Canada January 1st, 1990.
All right. What is the total amount owed to Burgess by each store? So what are they going to have? They're going to have their totals plus their shipping charge. How could we figure out the total? Well, you could technically just take matrix D and add up all the columns. Can you think of a mathematical way that we could do this? Matrix E would be just adding up all of the things in matrix D.
Shouldn't your answer be a matrix because it's by each store, not all of the stores combined?
Oh, that's so. Yes, this should just be D, right? The total owed will be D. So we've got P, Q, R, S, the total amount. We've got those numbers already here. 3172.20 2555 of 1. $2866.20, and finally 2550. $3019.2. So one thing to check, let's go back to our matrix A's. Do they match up with the question? Because it is very, very easy to type in one number wrong in a matrix. 70, 30, 22, 60, 20, 19, 70, 15, 24, 50, 40, 12. Mine matches up. If your numbers are different. Oh. You had 20? Okay. So we found the mistake in Allen's. Then check your matrix B. Do you have 8, 30, 75 in your matrix B? Well, let's see. Let's see your matrix C. Oh, your matrix C is 2960. Let's see. Second matrix C. You don't have 3110 in your matrix C? Okay, let's try A times B again. A times, and your A and B are the same? Maybe something happened when you stored it. Yeah, okay, it's all good. There's no matrices in the IB anymore. Hmm? Oh, right, because of the, yeah. So you haven't done this. All right, sounds fun. Okay. So then the total amount would just be adding these up. If we wanted to get fancy, what could I multiply matrix D by in order to add them all up? A row matrix of ones. Because all those ones would hit all the numbers, multiply them all by 1, causing action movie. And then you'd have to add up all those pieces. So if I wanted to do this on my calculator, I would have to add a new matrix E, make it, oh, I didn't want to do that. Second matrix, I'd have to go over to edit, add a new matrix E with 1 row and 4 columns, and make them all ones. And then I could go E times D, 11,143. It's actually might even be quicker than adding them all together. 0.5. You might have got them faster by adding, just showing that you could do it with matrix multiplication. The next question was written and designed pre-COVID. A virus hits the students in a school.
Oh, no.
Nurse Bertha discovers that people are either sick, well, or carriers. which is so crazy.
That is a shocking revelation.
I know. How can people have a virus but not show anything? Well, I guess it's possible. She finds the following percentage of people in each category in grade 11 and 12. This is mass testing. This is like you're living in China, they would find out, right? They know. Okay? Grade 11, 15% are well, 35% are sick, and 50%, it's rampant. Grade 12, 25% are well, 40% are sick, 35% are carriers. So what could we do? We could make this a matrix. We could have a matrix with percentages, 0.15, 0.35, 0.5, 0.25, 0.4, and 0.35. And this first matrix, this is well, sick, carrier, and grade 11 and grade 12. This is males and females, grade 11 and grade 12. So (104), 80, 107, 103. And now we can answer a bunch of questions. Okay. So again, we're going to go to our calculator and enter these in. When you're adding new matrices to your calculator, so I'm going to call this one matrix A, and this one matrix B. I go to edit matrix A, and my new matrix A has 3 rows and 2 columns. So when you do that, it just erases data that was there, and you can just type things over top. 0.15, 0.25, 0.35, 0.4, 0.5, 0.35. And matrix B is a 2 by 2, 104, 80, 107, 103. Okay. So some things that we notice here. This matches up with that. That's going to be important, and they're in the same order. So when you get to question B, say, how many males are sick? How many females are well? It would sure be nice if we had something that related males to being well and females to being sick and so forth. So if I took matrix A, get a new matrix. If I took matrix A, which, I'll leave some space underneath it, matrix A times by matrix B, I know that matrix A is a 3 by 2, and matrix B is a 2 by 2. And in matrix A, this is the important thing, in matrix A, this A stood for 11s and 12s, and that 2 stood for 11s and 12s, and that 2 stood for 11s and 12s. Not only do the middle numbers have to match up for matrix multiplication to work, the middle numbers have to stand for the same things in the same order to make matrix multiplication make sense. In other words, you will sometimes in word problems be able to multiply matrices and get answers that make no sense whatsoever. But you can get them. It's like, yeah, the following answers mean nothing. But in this case, since we had these two numbers make sense, we will get a new matrix. This new matrix will be a 3 by 2. 3 rows, 2 columns. The 3 will stand for well, sick, carrier, and the 2 will be male and female because that's what the 3 and the 2 stood for in the outside. This 3 stood for well, sick, carrier, and this 2 stood for male, female. Go to my calculator, go A times B. We've got a little bit of problem here. Okay? Yes. Half a person. So because we're dealing with percentages,
It says to round to the nearest whole number.
yeah, we will. Okay? Does it? There's some, I'm just thinking of issues. Will we have more people than we started with or less people than we started with when you round? So we have to make a decision based on that. But taking those numbers, partial people, they're in the process of getting sick. Okay, are we good with 42 and 38? 79 and 69?
Are you saying an amputee is less of a person?
Ooh, 76 and 89. That's right. I'm going to grow my hair long to be more of a person. How many males are sick? 79. How many females are well? 38. How many carriers are female? 76. And so here, I think it's really neat how you could use matrix multiplication to get a bunch of data quickly where, right, if I gave you this question on your integrals test, you all would have got, or tomorrow, if I give you this question on your integrals test and you hadn't ever learned matrices, I guarantee you could all figure it out. It's not extremely difficult mathematics that's happening. You're taking data and information and figuring it out. But it is kind of nice to see how seamless the math comes together. We rounded, right? We cut some people's hair. That's okay. 20% of your 20% of your body mass is hair. Well, those are the people who are in charge of cleaning up the hair. Woo! This is a lot of writing. This is where you're happy that you don't have to write the questions down. Yes, Alan. Ooh, alpha F4? Nice. So, alpha F3. Ooh, matrix. Enter. You make, oh. And then you can type it in there and then store it. Enter. I just made a 0 matrix. It's a grad gift. A sound company produces stereos. They produce the budget, the economy, the executive, and the presidential. The budget model needs 50 transistors, 30 capacitors, 7 connectors, and 3 dials. Then they tell the economy one, the executive one, the presidential one, and what is produced of each one every day. So we could put this information into okay. So we're going to make matrix A. We have to decide what we're going to do. We're going to go budget, economy, executive, and El presidente. And over here, what do we've got in there? We've got capacitors, connectors. Oh, transistors is first. You're right.
It's formatted nicely in our notes.
Transistors, capacitors, connectors, and dials. Now, had you made this first 4x4 matrix with the budget, the economy, executive, and presidential across the top, it wouldn't be bad. It wouldn't be wrong. It's just going to make a difference how we make all of the other ones after this. So now we have to put in our numbers. Budget is 50, 30, 7, 3. Economy, 65, 59, 4. Executive, 85, 42, 10, 6. And the presidente, 85, 42, 10. And look at all of those dials. Oh, that'd be a nice stereo. Okay. Now, daily manufacturing goal in a normal quarter, 10 budget, 12 economy, 11 executive, 7 presidential. Can you see for that one, for matrix B, if I wanted to do a daily thing here, I'm going to put these this way because rows and columns need to be matched up.
The other one is a 4x4.
I know, but I need to have the beep going across this way. But it's like something I can't say in this class. The beep. Okay, so we've got 10 budget, 12, 11, and 7. Yeah. There we go. I put D for daily. Okay? Oh, that's right. So, how many transistors are needed for each day? Capacitors, connectors, dials. So we need to multiply these together. Can you see that B, 1 row, 4 columns, we would need to go B first, because it's a 1x4, and this 4 stands for beep. And then multiply that by A, because A is a 4x4, but the first 4 was the beep. And we will get an answer that's a 1x4, where this is daily of transistors, capacitors. So again, if we wanted to find this out on our calculator, we would need to, I'm going to use that fancy new thing. I'm going to make a 4 by 4. Okay. Oh, and I need to go back to this screen. 50. Oh. Oh. I didn't want to have to use a different, I can't use enter anymore. There we go. 50, 30, over. There we go. You have to use the over button. 7, 3, down. 4. I don't know. I'm getting used to the over buttons. Ooh! That was on video, wasn't it? I said I'm getting used to how it. I thought I pressed to the left. Okay, see, 4, and then, oh, you have 3 times. That is annoying. I'll go to this one because, oh. Okay, watch. Watch this. 65 over. Perfect. 50 over. 9 over. 4 over. That works. 85 over. 42 over. 10 over. 6 over. 85. 42. 10. 12. And I'm going to store that as matrix, oh, matrix A. Bam. And then
You don't have to do it that way.
I know, but I'm trying this. This is exciting. 1 by 4. 10, 12, 11, 7. You're welcome. That way the person who's watching the video can. Oh yeah, that'll be good. Store matrix B. What math did we need to do? B times A. So second matrix B times second matrix. Wow. I'm so adept with these buttons. Yes. Yeah. And we got our answers. 2810, 1656, 2810, 1656, 358, and 228. TCCP, this was capacitors first, then connectors, right? And daily. So how many transistors needed each day? 2810. And I'm going to take that answer, and before I forget, I'm going to store it as matrix C. You were hoping I'd forget? And I'm going to make a note to myself that I made that matrix C up on here. During August, production increased by 40%. How do we increase something by 40%? We would take matrix B and multiply it by 1.4. 1.4, that would be 40% more, times matrix B. 14, 16.8, 15.4, 9.8. Wow. I remembered all the numbers. That was, it's on video. Just because I should maybe need this answer, haven't used D yet, so I'm going to store this as matrix D. This kind of makes sense. You could be almost done making something at the end of the month and not be done at the end of the day. So. Whew, that's a lot of words. Okay, awesome. The budget model takes 5 hours, 7 hours for the economy, 6 to produce the executive, and 7 for the presidential. How many employees are needed So now we're going to need to make a matrix, and the options are we could either make a column matrix with the hours, where we have beep this way, or we could make a row matrix with beep this way. And this will be hours or hours. So if we did the column matrix, we would have 5, 7, 6, 7, 5, 7, 6, 7. Now we need to figure out which of these is going to be useful based on the answers that we have. So if we look back at the answers we have, okay, here is the daily production, or this is matrix D. What did D stand for? This was beep this way, and that was the daily production there. So what are we looking for? If we took this matrix D, we would have to multiply it by a column matrix in order for things to work, because the beep would have to match up with the beep. What we would get is a 1-by-1 answer. So I'm going to take a 1/4 and multiply it by a 4/1, both of these being the beep. Matrix E was my 4/1, so the hours would be there. Matrix D was a 1/4, where the 1 stood for how much daily. What am I going to get as an answer? How many hours per day are needed? I'm going to go to my calculator, make matrix E. Five, 7, 6, 7. And now I can go B times E, 249. And that 249, the row was daily, the column was hours. That's how many hours we need per day. How would you figure out how many employees you need? Right, 249 hours divided by 7. $35.5. $36 people. Did I do the wrong one? Did I do? Oh, I said D and I did B. Thank you. Second matrix D by second matrix E. 348.6. Divided by 7. You tried that? 348.6. Hey, watch this. Watch this. Okay, clear. 340. This one, that answer. No. Watch this. There. Okay. Let's say you had that answer, but instead of dividing by 7, by multiplied by 1/7. Oh, I thought it would work. Oh. Yeah, let's try. Go to. Let's try with brackets. Would that work? I know, that's why I thought it should work. There it is. You cannot divide. Matrices division doesn't exist. But if the division happened to be a multiplication, that's perfectly fine. Oh, it's not the same thing, apparently. 49.8. You would need. It's how the calculator. Calculator can't divide a matrix, but it can multiply by a fraction, and so it's fine.